that quick intermission. And welcome to today's special panel. Today we're going to be talking about From Innovation to Collaboration, Propelling Ocean Exploration Forward to Meet the Needs of the Future. NOAA's Office of Ocean Exploration is leading this session, and the goal is to engage the ocean science and technology community in a discussion on ocean exploration initiatives, challenges, and importance of partnerships. So to kick things off today, please welcome Jeremy Wyrick, who is the Director of NOAA Ocean Exploration, a federal program dedicated to exploring previously unknown areas of our ocean by leading, coordinating, and funding expeditions around the world with a focus on deep waters. So welcome.
Thanks, appreciate it. Well, good afternoon. Thanks for joining us today, really appreciate it. To kick things off, I'm just going to be setting the stage for our panel discussion here, give you an overview of ocean exploration, and then talk a little bit about our interactions nationally and internationally, and then prime the pump a little bit on partnerships, public-private partnerships. Next slide. Okay, there we go. Quick overview, ocean exploration, been around for 20 years now, and fill in the gaps, basic understanding of ocean, filling the gaps with the U.S. Deep waters and seafloor, and delivering information that we can help make better decisions on the economy, health of the ocean. To do this, we have a dedicated platform, NOAA Ship Okeanos Explorer, the only ship federally dedicated to exploring our oceans, and also with our grants program, able to sponsor new technologies and different ways of interacting with the public related to other grant opportunities related to marine archaeology and and with our education outreach opportunities. What's nice about the program is from the very beginning, part of our DNA was working with education outreach, working right as we're planning our missions, planning our missions and making sure that we are engaging the public right off the bat. That's different than NSF, where it's a sort of a broader impacts come secondary sometimes. We want to make sure we're doing this right up front. And of course, we wouldn't be able to do this without our partnerships. That's key. One of our big partners is the Ocean Exploration Cooperative Institute. Our 5 partners for the Cooperative Institute: University of Rhode Island, Woods Hole, Ocean Exploration Trust, University of Southern Mississippi, and the University of New Hampshire. About a third of our funding goes towards the cooperative institutes, and this is a huge amount of our success for the program. Not only are they able to augment the work that we're doing with their own expeditions and their own technology development, but also the work that they're doing with ocean education and outreach. But the partnerships that they themselves make and are able to bridge for us have been key. We have some of those partners listed here on the slides, but there's much more than that. So most of the work that we're talking about here is related to science and technology. And the work that we do here with the program goes beyond just ocean exploration. And the work has a national and international aspects. I'm able to wear a couple different hats besides just Director of NOAA's Office of Ocean Exploration. One of the items up here is I'm co-chair of the National Strategy for Ocean Mapping, Exploration, and Characterization, NOMEC. That's a mouthful. But what that is, it's a way for the U.S. government to work together to map our own U.S. EEZ, working in collaboration with one another. So NOAA, BOEM, USGS, the Navy, we're the ones that are taking a good lead on this. And within NOAA itself, it's Ocean Exploration, the Office of Coast Survey. Related to NOMEC, for the Office of Ocean Exploration, we hit a big milestone last year. 2 million kilometers mapped last year with the Okeanos Explorer. We still have a huge amount of the ocean still unexplored, especially in our own US EEZ. So the work that we're doing in-house as part of our program, developing those standards, compiling data, making that data publicly available, is one of the huge assets for us, which is why we're leading the charge here with the NOMEC team. Tied in with that, though, internationally, is the working on the United Nations Decade of Ocean Science for Sustainable Development, or the UN Oceans Decade. The work that we're doing, the mapping work, exploration, characterization, those have applications with our international partners. They can not only use our data, but they can adopt the standards that we've been creating. Having our international partners, but also our industry partners, our academic partners involved in that discussion is key. Tied in with that is, tangentially, but along with that is Seabed 2030, a mapping effort to head out and map pretty much most of the ocean by 2030. It's a very ambitious goal. But what that requires is not only the federal government to work together, but us working with our international partners. Also, ocean exploration is involved with the blue economy. This is the new blue economy. This is a term that's been around for a while. All aspects of our federal government is involved in this, but for our purposes, it's related mostly to data and data archives, making sure that's useful and accessible. If we're going to go out there and acquire all this data, we want to make sure that people can use it. And also related to new technologies and updating the workforce. It's all about jobs. So what are the jobs that we need in the ocean environment today? What do we need for them tomorrow? And ocean exploration is part of that pipeline, especially in early career, providing internships, fellowships, opportunities, training opportunities on our expeditions. That's a key piece in all this. And climate change. The work that we're doing does provide that fundamental data and information that is available for users that are looking for expanding our knowledge on climate change, whether that's ocean modeling or the interaction that the ocean has with the atmosphere. We're providing some of that baseline information, or at least providing the opportunities for scientists to get out there and do that. So some of the challenges that we have, or opportunities when it comes to science and technology, really involve working with our industry partners on some of this. Much in the ocean remains unexplored. We have limited resources. So what is it that we can do to better use crewed and uncrewed systems for augmenting our crewed systems, our ships, whether that's surface, subsurface, uncrewed AUVs, autonomous vehicles. There's a better way that we can go out there and actually map our ocean or characterize our ocean that we're not doing right now. So part of that operation, how we can change our operations, I call it the O&M of ocean exploration. How can we do that better? Complete coverage of the USC by 2040, which is an ambitious goal in NOMEC, requires increasing data acquisition, data processing, manipulating that data, huge data sets. How do we do it? How do we do it better? How do we make that more accessible? And then discovering and characterizing life on the seafloor or in the water column. That's a hugely human endeavor, meaning human interaction. And how can we use artificial intelligence to better look at our data, catalog our data, see what's out there. If we're having to have just eyes on target the whole time, it's not really a very efficient system. And finally, to help set the stage, I want to get back to one of the other interagency working groups, national hats that I wear as co-chair of the National Oceanographic Partnership Program. For those who were here for the plenary presentation yesterday, Tom Drake from the Office of Naval Research gave a really good pitch for this program. Office of Naval Research has really started this program, kicked it off way back in the day, but it requires all federal ocean partners, ocean agency partners, to come together and collaborate on these projects. It requires multiple partners. It requires partnership with academia and certainly with industry, or we'd like more of that with industry. There's a term out there called NOP 2.0. What this really means is taking NOP to the next level, seeing how we can expand those partnerships, seeing what we can do to make sure that we bring industry more at the table, provide those funding opportunities that aren't there right now. The big takeaway from this is, again, this is NOP, we're getting into some beltway speak, But what you need to know is that the federal government is working together and has been working together. And that coordination, in order to involve that other partnerships with academia and industry, has to start with the federal government. And it requires the federal government to come and provide those opportunities, but to help to provide those big ideas. What are the next challenges? You all have those ideas. You've all been part of those conversations. But how do we implement them? And so that's a key part of NOP. I serve as a co-chair working with Reggie Beach over at Office of Naval Research. And I'm pretty anxious to have that program launch off to the next level. And so with that brief introduction, I'm going to pause, and I'm going to turn it over to Dr. Sarah Kapnick, NOAA's chief scientist. In her role, she's responsible for advancing policy and program direction for NOAA's science and technology priorities. And so I will welcome her to the stage. Thank you.
Jeremy, thank you for that. A wonderful introduction, for all the attendees for coming, and for the MTS local committee for all the organization efforts you've had to undertake. At NOAA, we are investing in advancing science and technology for the greater good of understanding, protecting, and responsibly managing our oceans from the surface of the seafloor, and ocean exploration specifically aimed to provide the baseline information to do just that. For example, climate within the administration and also at NOAA is a priority, and ocean exploration can further our collective understanding of changes to the ocean processes due to climate change by collecting, providing baseline data that can be used in climate research and applications. As a federal leader in ocean science, we have a responsibility to deliver products and services to the nation and world in support of that greater good, but we acknowledge that we cannot do it alone. NOAA continues to prioritize building and maintaining positive and strategic partnerships with experts and practitioners in industry and across the ocean community. And we have seen the good that comes from joining forces and hope to only improve and expand on our partnership efforts. For example, we have a Saildrone with us today. This past August, we had an interagency public-private partnership between NOAA through the Ocean Exploration Cooperative Institute, the Bureau of Ocean Energy Management, and the U.S. Geological Survey, and Saildrone that resulted in the Aleutian Uncrewed Ocean Exploration Expedition using Saildrone Surveyor, the world's largest and most advanced uncrewed surface vessels for ocean exploration. That expedition's goal was to collect ocean mapping and environmental data in unexplored waters around the Aleutian Islands, one of the most remote areas of the United States. Saildrone's survey spent the summer surveying in the Aleutian Islands, meeting data collection goals set forth by the government and our academic partners, despite rough seas. Surveyor is now making its way back to California to complete the remainder of the work for this project on the West Coast. This is a great example of testing new technologies with companies as a way to reimagine our observing systems and push the boundaries of technology that is needed to better map unexplored areas of our own territorial waters. As a second example, I would like to bring up FathomNet. I've been hearing this around the conference over the last few hours, and many others have brought it up to me. It's been talked about a lot about this company, and they have demonstrated the really power in public-private partnerships and technological innovation. FathomNet is an innovation in machine learning that will improve how visual ocean data can be labeled and curated in real time when combined with ocean exploration technologies. FathomNet is an open source image database that uses artificial intelligence to track and identify ocean life. This is a collaboration between Monterey Bay Aquarium Research Institute, NOAA, Sea Vision AI, and the Ocean Discovery League, and will benefit not only analysis, but data management and even data collection. We can use the algorithms that are and will be developed to help people find ocean imagery, use it, and then even in the long run to collect it over time. In NOAA, we are supporting industry at different levels through different programs to help promote such innovation. For example, in NOAA's Small Business Innovation Research Program, or SBIR, we aim to stimulate technological innovation in the private sector, providing funding to small businesses to establish the technical merit, feasibility, and commercial potential of a technology in the foundational stages. Awards are given for phase 1 of $150,000 and up to $500,000 for phase 2. The program also provides education and support to entrepreneurs through the process of researching, developing, and commercializing technologies. Currently, phase 2 awards have access to the Commercialization Assistance Program, a mentoring and training program that includes one-on-one engagement and is dedicated. For my time in the private sector, this is really critical for early stage companies to actually grow as they go through the trials of growing from concept and the technology to actual commercialization. We also are creating formal agreements with companies beyond SBIR. We use the Cooperative Research and Development Agreement, or CRADA, as one of the easiest, most flexible agreements for working with NOAA in the private sector. A CRADA is a written agreement between a private U.S. company, university, or other entity and a NOAA laboratory or science center to work together on collaborative research and development projects. Under the CRADAs, NOAA may contribute staff, facilities, expertise, and intellectual property to collaboration, but not funding. For example, in the Great Lakes, we are working with Viking on collecting information across the Great Lakes. NOAA understands that partnerships are not static. Challenges arise, and flexibility is required. In addition to discussing thoughts and ideas, one of the goals for today's panel is to hear some of those challenges and ways to potentially overcome them and to improve ocean exploration for the whole community. I'm excited and honored to moderate this special panel today and would now like to introduce our panelists and welcome them up to the stage so we can discuss robust ideas on ocean exploration. For time purposes, I will be sharing their names, titles, and affiliations, but I encourage you to visit the conference agenda and link for the session about their impressive backgrounds. So I welcome you guys up. Joining us today, we have Dr. Adam Sewell, Director of NOAA's Ocean Exploration Cooperative Institute. We have Ms. Tosca Lichtenheld, Government Business Development Lead at SOFAR Ocean. Online, we have Dr. Kukani Kutiju, Principal Engineer at the Monterey Bay Aquarium Research Institute. She is also a FathomNet co-founder. We also have Mr. Brian Connon, Vice President of Ocean Mapping for Saildrone, and Jeremy, who you also just met, Director of Ocean Exploration, who you've heard from earlier. So to start, the opening question that I'm going to pose to everyone so they can all respond is, based on your experience, what external, non-federal actions or partnerships have had the highest impact on advancing ocean exploration to date, and what non-federal activities aren't happening today but could occur to better help NOAA and the ocean exploration community as a whole? So let's start with Adam on this first question.
Thanks, Sarah. That's a great question and a little tough to answer because the federal government has been so deeply integrated with all the work we do in the ocean. But what came to mind for me is kind of the esoteric concept of market forces. You know, when you think about it, the oil and gas industry holds the largest share of ROVs and AUVs out of any sector that's in the oceans, including, research. And they've grown to the point where now access to the oceans is pretty routine. And that's a fantastic foundation because from that, I've seen this shift from innovation happening only in kind of academic labs to now being this whole constellation of academic labs and small companies and big companies where the innovation is happening. So it makes me really optimistic about what we're going to see coming down the line. And the other cool thing about it is that with these small companies, we're seeing a shift from building stuff that is going to help us answer scientific questions to building stuff that's going to create new markets and that's going to drive innovation that, as an ocean exploration community, we're going to ride the coattails of and have a lot of success from. And I think that, going forward, the federal government has a big role. There's so many of these companies out there building sensors or systems. Many of them are not going to make it, but we don't want them to not make it because they didn't get a chance to put their gear or their algorithm to use in the real environment. And so, within the Cooperative Institute, we've developed a few of these partnerships to take some of this innovation and bring it out into the field. And I think hopefully we're going to see a lot more of that through time. So.
Thank you. Ms. Toska-Lichtenheld, would you like to go next?
Yes, thank you. I would double tap on market forces. I think there's an emerging demand for ocean data, and that has spurred a lot of innovation. But there's also been enabling technologies that have occurred over the past 1 to 2 decades that have enabled new exploration that wasn't possible before. So things like ubiquitous satellite communications, high-scale cloud computing being very affordable and accessible, as well as sensors becoming a lot smaller, a lot cheaper, and also more connected. And with those enabling technologies, you're able to have ocean big data, essentially, which opens up new pathways for things like AUVs, being able to navigate better, being able to use ship time in different ways because you're getting this data from new sources. But in terms of things that could really accelerate change and make it move faster, I think that modularity and alignment around standards, whether it's for data standards or hardware connectivity, will take us to that next level with ocean sensing. The ocean environment is incredibly harsh, and it's really hard to explore using something that maybe you used on land, and you think, oh, it's easy, I'll just toss it in the ocean, it'll work. No, it's not that simple. But there are a lot of people, many of them are in this room, who have spent a lot of time investing in making technologies workable in the ocean. And how can we make those technologies work with each other? That will open up a lot more exploration opportunity.
Let's go virtually next. What is your response, Dr. Katya?
Yeah, thank you. So I think for me anyways, when I evaluate the field and what's going on, I think what we're seeing in open data is really, really exciting, because if you have data pathways or data pipelines that the community can agree upon and then subsequently use, then it doesn't matter so much in terms of what kinds of hardware you might be using, right, to try and do similar or same measurements. But in particular, I love to use the example of, the Argo program or the biological, so the Global Ocean Biogeochemistry Array, because this is a program that's, originally NSF funded. I know there is some support from NOAA as well, but the idea is that, deploying hundreds, if not thousands of floats throughout the global ocean and providing or sharing data almost in real time and having it be available to the community has been hugely impactful for, the physical oceanography or the chemical oceanography communities. But we need to see a similar revolution also in biological observations. So I think that is a really exciting area where I think we should be thinking about a lot as we move forward.
Dr. Conlon?
Thank you. I saw this question and kind of like Adam, it was like, well, that's kind of a hard question. But then I thought about what got me excited about ocean exploration, and it's really been the effort of a lot of nonprofits and passionate people. And so when you look at Ocean Exploration Trust, the Mid-Ocean Institute, the 5 Deeps project that just completed, all of those things really brought to light the wonders of the ocean and why we need to explore them. And I think those have had a profound impact because they are pushing the envelope, taking manned submersibles to the depths of the oceans, really moving forward RVs. Now there is, again, federal funding associated with a lot of those, but I think it's the passion of those people and those organizations that really kind of have moved things into the limelight where you can actually see them and the telepresence that they do and that is done through OECI, things like that. I think that really kind of brings to light, brings more people into that. And that's really important, I think, for reaching, as Bob Ballard would say, you've got to hit the middle schoolers, right? You've got to get them early. And so if you can visualize it. So I think those things have been really important. Even though supported by federal funding, a lot of it was also private funding. So I think that we need more of that.
I'm trying to look in here. We had some high schoolers in here that just popped in and keep popping out. This really is what people get excited about.
Right. I mean, just look at her backdrop. That's like the coolest. Yeah, look at that.
So For the next question, to open it up, and then please, you guys jump in as you want. What are some of the top science and technology readiness challenges within the industry, and how can academia and government be involved to move the whole ocean exploration community forward? How do we all work together?
So I think we have a common, across ocean exploration, characterization, mapping. We have a common need for autonomy and automation, machine learning efforts, big data efforts, as Tosca mentioned. So, I think that's where, my goal for our company would be, we're mapping directly into a cloud bucket that is automatically running an AI processing system and providing that data, in near real time as it's coming off the vehicle. You have to have really good comms to do that, which we're not there yet. You have to have systems on board that can actually run that automated routine to collect that data. And if for those of us who've worked on survey ships and sonars, they're finicky systems sometimes. And so, we're talking to our vendors, and I was just talking to the Kongsberg folks today about design systems that are built for an uncrewed system, whether it's below, on, or above the ocean. If you build it for an uncrewed system, it will work on a ship or an airplane or a submersible. So, kind of change the paradigm there, make these very robust, simple to operate, making efficient use of low bandwidth communications. All of those things will allow us to get more data more quickly, and scale up the number of systems we can actually put to sea to do this ocean exploration.
Yeah, I'll add to that and just reinforce something both Kakani and Tosca said about having good standards. A colleague of mine, Alan Adams, really hammered this into my head, and even after I kind of argued with him, because I was worried that having too many standards kind of stifles creativity. But what he pointed out is that it actually enhances it, because if you do not have to think about what the pinout looks like on your connector or what the form factor of your pressure vessel is going to be, you can think about more exciting things about how to add a new sensor, how to have a different operational concept. And I think this is actually a fantastic role for the federal government to play, to be a kind of convener to develop these standards. And I've seen standards try to be developed. What you end up with is a much smaller, simpler set of standards than you had as an ambition. But having those is really important and is going to save a lot of time and money and effort as we build next generation tools and algorithms. So.
Yeah, I want to double tap on that, because that you basically took exactly what I was going to say. We need better standards. That is what enables creativity right now. Because, again, the ocean environment is so harsh, instrumentation can end up taking up a lot of your time, and the cost is excessive, and that ends up using up a lot of your budget. And then you don't have as much time for the exploration or for the analysis, which is really what we should be after, is deriving new insights. It also prevents up-and-coming scientists, engineers from participating in ocean exploration. In an ideal world, right, like a high school student should be able to put something together that is able to, through citizen science, discover something. And having hardware standards that enable more of a plug-and-play infrastructure. We're not even close to being there yet, but it's something that can really drive us forward, because we have a lot of platforms now. There's sail drones, there's SOFAR buoys, there's existing NOAA buoys, there's all kinds of platforms. How can we enable anyone to get a sensor onto those platforms in a very easy and low risk and low cost way? I think standards are a path forward on that. And the federal government can play a role not only in developing those standards, but in incentivizing the use of those standards. As soon as something becomes a requirement in an application for a grant or an application for funding, people are going to do it because they want to get that money. So I think that the government can really play a role there.
Virtually?
I will add to this because I work with a lot of software engineers, and there's an XKCD. I don't know if you guys are familiar with this comic, but if you create, a standard, you've added another standard to an already long list of existing standards. So I think what is really required, right, is for the community to rally around and accept that standard. You want to be very careful, right, dictating a standard, because there may already be standards that exist in the community that just haven't had, high enough uptake, to really move the technology and the systems engineering forward.
If I can add to that, in terms of what already exists. So one of the things that government has a responsibility for when we talk about tech transfer, it's not just a matter of technology coming out of the government and into industry, but from one government agency to another. There's been a lot of investment made on the defense side that the non-defense community could definitely take advantage of. Ways of operation, technology, sensors, that, as a program manager for an ocean program, I don't want to see us investing in things that have already been, problems that have already been solved. But we love to use them in new ways. And it's something we have to be mindful of as we work with industry, as we work with our academic partners.
Thank you. Switching a little bit to tech creation, innovation, operations, we wanted to ask what research to operations or development to operations investments are needed to further operationalize innovation through the academic, government, and industrial fleets. Everything, nothing, anything top of mind?
I can chime in. So first, I think there's some really great existing programs, and NOP is one of them. So I'm glad it's getting a lot of attention as part of this conference. That really helps with maturing technologies and sharing. Like you were saying, it's not just about sharing from government to industry or vice versa. It's also within government, maturing and sharing how technologies can be used in different scenarios. But there's a saying, and I've heard it more on the defense industry side. I haven't heard it as much on the civil side, but there's this phrase called the Valley of Death in contracting. And there's a lot of excitement around the initial research and development of a new technology. And there's a lot of funding too. SBIR is a fantastic program. It's really good. There's grants, there's NOP. There's a lot of programs that do those lower TRL investments, and those are excellent. And then what comes next? It can be really tricky to transition from that initial prototype or even a small scale successful program to something that becomes widely used or used in different contexts or used by different agencies. And right now, there isn't a very clear pathway or defined set of milestones to hit. And so if there's ways that the government can support that transition, I think that would be really excellent. An example of someone who's doing this right now is the Army just rolled out last week or 2 weeks ago a new program called Project Vista. And they're specifically looking to support companies that have already received a SBIR to actually get onto operational contracts. They're also devoting funding to specific technical problems that haven't yet been solved, and looking to industry to help with those solutions and giving them opportunities to test their solutions in operational environments. So that's maybe one model. And one other thing I think that they're doing that's really cool is they're setting up an R&D portal to see who is already funding solutions to these programs. And maybe it wasn't Army, maybe it was somewhere else, or maybe it was a different group. But someone might have already done research on this and might have already taken the first step. So how can we leverage what's already been done and bring those people together?
Yeah, I think, a subtext to what Tosca's saying is that the development and maturation of these technologies takes quite a lot of time, and it's not necessarily a timescale that aligns with funding cycles. It might be a 10-year process to get something from a prototype to an operational status. And I will give a lot of credit to NOAA Ocean Exploration, because within the Cooperative Institute, they've recognized that, and we have some technologies that we're bringing along step by step till they're ready. And Kakani just got a big award from NSF for FathomNet that has a kind of, I think, a 5-year time horizon, which I think is, good and maybe should be even longer, but there needs to be, the things you mentioned are great because they're recognizing that it's not a 2-year project and then you have an operational tool. It's really kind of decadal in scale.
Yeah, I want to add, thanks Adam for calling that out, at least 2 programs. So the one program that, Adam just called out was the NSF Convergence Accelerator Program. It's a 3-year program. It's broken down into phases, where phase 1, you are involved heavily in user-centered design, which is something that I don't think we do enough of within the ocean technology space, and thinking about what are the real problems and how do we create solutions that actually, address them. And then you spend the entire phase 1 process coming up with, an idea, a product, or an outcome that you then pitch, for a phase 2 and then subsequent 2 years. So it's an interesting program. I recommend people check it out because it's not just academic, it also is for industry and government partners as well. And I think, of course, Noah, you all know about the IU's Ocean Technology Transition Program, which advances technology through that valley of death phase to help get, sensors, et cetera, and platforms to operations. So I think those are 2 really great examples on ways that can be done.
Yeah, I would just add that, having programs of record being established are at the whims of administrations in some cases. And so, R&D that was supporting a project may find itself with no operational program to then roll into. So the valley is endless. But there's also strategies come out, strategies like NOMEC. Industry sees a need and develops the answer, and it only took 6 months. So we also need the ability to do a rapid transition of technology into operations. So, the R&D from your basic science all the way through to a functioning program, but also either through small business initiatives or rapid transition initiatives allow the technology to come into the federal government programs and be used right away, instead of having to wait and, go through the process of getting it into a budget line somewhere in someone's budget. So I think all these things have a purpose, but there is a lot of movement in industry, and we're outpacing the budget cycles of the federal government. And that's frustrating to us that we can't, get our technology to help address the issues that we know are there because they've been published. So I think that is another area that could use some work.
Given the suite of available crewed and uncrewed platforms today, so where we are today, how could NOAA better incorporate new technologies to augment its at-sea assets and maximize operations to explore swaths of uncharted ocean and full ocean depth, or even change the paradigm of exploring the ocean overall? So if you could rethink what we're doing, what comes out of your brains when I ask that question?
I mean, obviously, from our company, that's what we're thinking about all the time. But I think the fact that uncrewed systems are here to stay. They're only increasing in capability, and you can scale up very quickly because they are not these large shipbuilding programs that take years and cost millions of dollars. You can actually scale up very quickly and address problems, scale back down if you need to. So I think it's going to have to be a shift within the federal government. This isn't just NOAA. Navy is the same way, where the way we've always done it is we've used ships and people. As we look at using uncrewed systems, one, you've increased the safety of your people because they're no longer subject to those. Two, you can scale up the quantity of data you can collect very quickly at a much lower cost. And three, which everyone has in the back of their mind, generally these uncrewed systems are very friendly to the climate. They're very low carbon producing entities. And so when you think about how much carbon is burned in fuel on a ship per day, but also how much heat is going into the ocean. The engines on our ships are pretty inefficient, and you've got a lot of heat going out the stack, but a lot of it is going into the ocean itself. And so how do we take advantage of these systems? And I'm not here to say that we want to replace a ship. That's not our mission. Our mission is to do the things that we can do really well and allow the ships to do the things that only they can do. And that's using ROVs, dropping CTD rosettes, launching AUVs, all of those things that requires someone to go out and do that exquisite work. But when you're talking about ocean mapping, it's like mowing your lawn. You're just going back and forth. And so why not let a robot do that as one example, and allow that ship that you're paying a lot of money for and those people to do those other special missions.
Tosca, do you want to add?
Yeah, I mean, I agree with everything you just said, and it's really about leaning into our strengths and taking advantage of what our strengths are. So one thing that we're doing so far is we're trying to have persistent monitoring of the global oceans, characterization, and that enables new forms of ocean exploration. I like to think of data analysis being the new ocean exploration, right? You don't have to be on a ship or in a submarine to be an ocean explorer. You can be exploring through the data that's available to you, and that can be coming off of autonomous or unmanned platforms. And that's something that we're good at, but we're not good at things that only humans can do. So exactly, lead into the strengths of each type of sensing technology or each type of platform and use what it does best. One of my favorite quotes is from Grace Hopper. She says, the most dangerous phrase in the English language is, "We've always done it that way." And so I really think that's true, right? We shouldn't be doing something just because we've always done it that way. It's a time for a paradigm shift, and maybe even taking another look at what we mean by ocean exploration. And I really think that, big data is the new ocean of exploration.
So with that, I feel like we have to have Kukani give a comment. Big data, thoughts, AI. Do you have
I
thoughts
totally agree with everything that's been said. I mean, it's something to keep in mind, right? It's like, as soon as we get all of these instruments and vehicles and systems out at sea, it's like, what are we actually going to be able to do with all that data? And, they're thinking about autonomy, thinking about artificial intelligence, thinking about how these algorithms will magically be able to help us, operate large swaths of robotic vehicles. And I think there is still a human element in all of that, right? There's the fact that humans have to interact with these robots, or humans have to interact with this data. And so thinking very carefully and clearly about, what do we know with human-computer interactions or human AI interactions, and how can we create systems that will enable the most effective collaboration between those two entities, right? But then also thinking beyond, the one or two individuals that might be operating a robotic system. I think it's a really exciting time where we can engage a large swath of people, all right, beyond just, researchers, oceanographers. There are clearly things that we can do to not only, engage a much broader audience, but also have them be a part of ocean exploration. So these are things that we're thinking about in terms of gaming and automation of visual data and, searching for novel life in the ocean. And we think that that is a hugely engaging area that can bring in more people into this, this realm of ocean exploration. So I think it's a really exciting time to be able to combine all of these things and rethink how we might be doing ocean exploration into the future.
I agree. The only thing I would add is that as we have more and more uncrewed systems, we have so much potential for growth in how we're using autonomy to operate those systems, to operate them together, and with humans. There's just a tremendous growth potential in being able to scale up, but not necessarily having to scale up with as many people as well, that letting these robots make some intelligent decisions for themselves, which right now is mainly obstacle avoidance, but it could be, what's the interesting thing, and I'm going to go look closer at it.
Yeah.
Just real quick, because for ocean exploration, we're providing a pretty good opportunity, especially on the front end, but also on the back end. So on the front end, have the ability to test out new systems on new platforms. But in the case of working with Saildrone, it's actually changing the way that we're actually going out there to explore the ocean. It's augmenting our work, augmenting our crewed systems. But the important point that I'm hearing too is the automation across the whole data pipeline on the front end, from data acquisition all the way to the back end, to how we use the data. We talk about the valley of death when it comes to contracting. There's also the data mortuaries, to carry on a grim analogies here. I don't want to do that, but we want to make sure that whatever we acquire on the front end can be used on the back end. Yeah, it's ones and zeros, but boy, that's good information for someone down the road, and we have to get it in the right hands. And so we see it from the whole pipeline.
And so with that, in the discussion of efficiency and automation and everything that's exciting, sometimes I think we get lost in those discussions of we still have purposes for ships, and since they are higher costs, how do we properly use them going forward to be able to make sure we're getting the best value? And with that, have any of you thought about what technological advances could increase the value of that ship time needed to deploy the assets? For example, concurrent operations, multidisciplinary operations, or increasing the speed operations. What technological advancements need to happen to make sure that we're effectively using our entire suite of capabilities that are coming to pass?
This is something that the Ocean Exploration Cooperative Institute has been very interested in, and we've slowly been growing our set of tools, and in the past year or two started to deploy ROVs, AUVs, and surface vehicles at the same time. And it's fantastic because we're getting a full picture of the water column, and finding that what we can see at the surface has an impact on where we should be looking in the midwater, and impact in the benthic environment as well. And it's pretty obvious that the more vehicles you can put out at once, the more information you can gather, but there's some big challenges with that. Currently, each vehicle comes with its own operation team, that's 5 or more people, and they're filling up the entire ship, and there's no room for scientists. And there is the desire for the robots to communicate with each other, but it's a very low bandwidth environment. And so we are working on ways to kind of use telepresence to kind of push forward teleengineering and teleoperations, and Saildrone does a wonderful job of this, of having basically all the operations on shore, and figuring out how we can use onboard computing to reduce information down to the kind of critical pieces that need to be shared between vehicles or between humans and the vehicles to redirect them in the right way. But I think that ship time is so valuable, and the people out there who have expertise are so valuable, that you want to take best advantage of that. And that's not looking in one place at one time. It's looking throughout the whole water column.
Any other takers?
Yeah, I think maybe to expand a little bit on what you're talking about of onboard computing, and what does that mean? It means something a little different, I think, to all of us. But what we're really trying to do is how can we quickly, do some analysis on scene, not just collect the data and then analyze it further, but how far can we push that, real-time analysis of what's going on? Simple scenario, mapping with a USV and understanding what your swath width is, and can you automatically adjust the next line based on what your swath width was. And that sounds fairly simple to do, but now that system has to talk to the navigation system of the USV and do it quickly enough so that you don't miss that next line. So just those types of things are things that we're looking at, but we're also running machine learning with our camera systems on board the vehicle that allow us to push off the vehicle the critical information that someone needs ashore from that camera system, whether it's spotting marine mammals or spotting shipping, doing a surveillance type of role. So I think there's a lot more of that to be explored, to do the analysis and then see how smart, with quotations, can we make our sensors when they're down there. Right now, AUVs primarily do a pre-programmed mission, and they just follow what we've told them to do. at some point, they should be able to make the decision of, oh, that looks like something I need to either descend and look at closer or make another pass, whatever. I think we're moving in that direction.
Connie, I thought I saw you take a breath.
Oh, I will add to that if that's okay.
Oh, no, yeah, I was calling on you.
Oh, you were. I can't quite see. Well, I have so much to add to this. I think really, what we're trying to get to, right, is to have a persistent presence, know what's happening generally in the ocean, across spatiotemporal scales, but also be aware or be able to, target and sample situations or activities that, might not happen all the time or, might be different. And so that's a targeted sampling. And so being able to achieve all those scales is going to be important, and these different systems, be it shipboard systems, autonomous vehicles, surface floats, et cetera, can all play a role across that spectrum. I mean, one example I like to think about or share is, MBARI does these multi-vehicle collaborative missions every summer. And I believe Saildrone may have been involved in one of these activities last year, where we have, LRUVs, wave gliders, multiple research vessels, and, others all working cooperatively together. And now we have autonomous systems or AUVs that have algorithms that are actually trained off of FathomNet data that can distinguish between different types of animals that the imaging payloads that are on our AUVs are detecting. And then now being able to get that image data off a vehicle thanks to a tracking surface vessel that then ships this information in real time to a human user through their email, right? So thinking about ways in which we can couple these autonomous systems with smarter algorithms and AI to create these episodic alerts that can key in a human user or a human in the loop when their expertise is required. So I think it's a really exciting time to start thinking about combining all these different modalities of sensing, because I think they all have their strengths and can get us right to that persistent presence and targeted sampling goal.
I'd just add one thing to what Kakani said, is that when we start to use multiple vehicles together, I think we start to see some kind of emergent behaviors or ways of looking at the ocean that we didn't anticipate. And we've had similar experiences to what Kakani said, where all of a sudden we've kind of developed a new way of sampling eDNA that's targeted by a bioacoustic sonar from above that's putting the sampler in exactly the right place. And there's going to be more and more that we start to discover in the ways that we approach the collection of data and samples that we didn't think about before when we start to put these different systems together.
Yeah, I'd agree. The heterogeneous network of sensors is really the future, and it's already where we are now. But how do we make all those pieces work together better and work together in a way that makes the most sense for what they're uniquely good at? And so I love what you were saying, Connie, about alerting. If we are able to have persistent presence that's very low cost, maybe it's not very high resolution, but persistent presence where you can get alerted when there is something anomalous or interesting, and then you send a more targeted AUV or a person on a ship or some other type of sensor to go look at it more deeply, then you're making the most use of what you have, and you're catching more, like you're seeing more, you're exploring more, as opposed to going out without having that prep work done. Like in a way, having a persistent network does the prep work for you, so you know where to use your resources most effectively.
Any last word, Jeremy?
Well, just adding to that, one thing that we've seen in government, especially within NOAA and all ocean agencies, is, part of having that ecosystem is knowing what the requirements are. So if government is your customer, government needs to be very clear on those requirements, because sometimes those discussions come out of saying, well, I need that platform, I need that ship, or I need that sensor. Well, what do you need it for? for us, as someone who tries to help be a catalyst for some of that, we have to try to mine that down, because it doesn't do our partners much, gives them much help if they don't know exactly what tools they have to be able to add to it.
One more thing I forgot to mention before, but just to hammer again on standards and modularity, having a heterogeneous network makes things a lot more complicated. And so if you actually want to have that effective alerting system where there's different systems that are working together and maybe they weren't designed initially to work together, what's that bridge that connects them? And standards is one way that you can have that bridge.
Okay. Thank you for this lively conversation that we generated, but it's getting late. I want to make sure that we open this up both online as well as the audience here to also be able to ask questions. So there are microphones there that you can go to, and we'll take the first one in the room, and then I think I have someone who has the remote ones too. So remotely, please also send your questions in. We'll get to those as well.
Hi, Amanda Knepper, and I'm coming from the White House Office of Science and Technology Policy. But I'm actually going to steer clear of the hard policy questions, though I do have lots of them, and want to kind of throw out a fun question to this group. So, part of what is so inspiring and exciting and kind of drives ocean exploration is that serendipity, that sort of like going out and looking for the things we don't know and we don't even know what the questions are and don't expect to find, right? That's sort of what distinguishes it from observation or monitoring. And so I'm just curious to hear from each of you, like what are some of the big unexpected finds that you've seen, either in real time doing ROV surveys or as you've gone back and dug into the data, like where's that exploration moment that you've had?
I'll share a fun one first. So we've been working out in the Central Pacific on Cretaceous age seamounts. They're completely covered with iron manganese crusts, and of course people are interested in those for the rare metals, but we had been picking up some kind of broken up pieces of this crust and brought them back to the lab, and recently saw a little serrated edge on one of them, and we peeled off the crust and we had a megalodon tooth within this manganese nodule, which was very cool. And just one of the things that, as Amanda said, if you never know what you're going to find when you go out there. But there are other kind of more scientifically relevant ones. That one was just kind of cool.
Kukani?
I have so many, but I'll tell you my favorite. As some of you might know, I've done a lot of research, kind of for fun, but looking at giant larvaceans, which are these basal chordates, small gelatinous animals. They look like tadpoles. They never change their plan form or whatever. And, a couple of years ago, we developed a laser imaging system that allows us to not only, measure how much fluid these animals are processing while they're eating, and this is like an instrument that's deployed off a remotely operated vehicle, but we can also do full 3D reconstructions of an animal inside of its mucus house, or snot palace, as I like to use as a descriptor. And I work closely with Bruce Robeson. He's a senior midwater ecologist at Anambari, and he told me, so it's been years and years and years of looking at these animals and having this view of these animals just using the white light illumination that we normally have on ROVs. And the first time we turned on the laser for DPAV, where we could see clearly inside of the animal and inside of this mucus house, I remember hearing Bruce in the background just oohing and awing at what he was seeing, right? But I think the thing that was most exciting for me is that we accidentally came upon an animal building its house from scratch. And so it was secreting mucus from cells lining its head and then blowing it up using, its tail. And these structures are they're called giant for a reason. I mean, these mucus structures can be about 1 to 2 meters across. And we saw this animal build and expand a house completely in less than 45 minutes. So that was a huge shocker, but also really incredible to see. Something I'd really love to figure out how they do.
Yeah, for for me, and currently, I think a lot of people like to use Google, right? So you go in and you kind of zoom in on Google and you see the ocean floor that's depicted there. And there's a lot of features kind of there, but you don't realize kind of the scale of that until you go out and actually map. And so we mapped a transit from San Francisco to Hawaii and back. And just seeing that topography of the seafloor that is not present when you're looking at it at much different scale is always amazing to me, to know there's so much down there. And we were finding seamounts and other features that were not depicted that are probably going to be something we want to go back and look at more closely. And I think that's the real power of mapping from the surface, understanding at a good scale what's there, and then being able to prioritize what you want to go back and actually look at with an AUV or an ROV. And so that's been the exciting part for me. Now, when I was in the Navy, threw a side scan on the water in Apra Harbor in Guam, and the very first pass caught a World War II freighter sitting on top of a World War I freighter, one Japanese, one German. Beautiful side scan pictures. So that was probably my coolest moment of personally.
It's cool. Yeah, I love the concept of finding something you weren't looking for, and that's where I think when you're always looking and always sensing, it creates those opportunities. So our global network of spotters has been out in the open ocean, and a few months ago there was a strange anomaly in the data, and one of our data scientists went to go take a look and see, like, is there some kind of glitch? What's going on? No, our buoys picked up the Tonga earthquake, and that was something we didn't design buoys to look for earthquakes, but wow, we caught it, and you could actually see how it was propagating across the entire global network of 800 some buoys. And if you do the science, like, it really matches up to how the wave propagated, and that was just really, really cool.
It was cool.
I was involved with one from that same Tonga eruption. Some colleagues went out to the Lao Basin Spreading Center, which is about 100 kilometers away, to look at the hydrothermal vents and the animals there, and found that it was buried under like 60 centimeters of ash from this eruption. And we have no idea how submarine eruptions and the ash is dispersed through the oceans, but this is a really cool example of a natural event that really disrupted the seafloor, probably has relevance for how humans are going to disrupt the seafloor, now and in the future. And it was just the coolest thing, to go out there for one purpose and find something else. And that's not uncommon when you go out on a research expedition, to go out for one reason, but the most exciting thing that happened was not what you were expecting. So exploration is just so cool, and almost every time you go anywhere in the ocean, it's a part of it,
Real briefly, we talk a lot about technology, we talk a lot about data for oceans and some of our partnerships, but I think one of the things that really impacted me was that human connection that we have with the ocean. And to kind of dovetail with what Brian was saying, sometimes the marine archaeology aspect that we're doing brings people together. We see it with our ocean exploration, we see it with our education outreach components. Years ago, I was working on a project with Dr. Ballard's team, Ocean Exploration Trust, before they were part of our cooperative institute, and we were exploring a shipwreck, a 2,000-year-old shipwreck in the Black Sea. Black Sea is an environment that's pretty much mostly anoxic when you get down to depth, very well preserved. And so using an ROV to go in and uncover this ancient shipwreck, and at the top of the mast, there's still a knot on rope that someone had tied 2,000 years ago. You see the wood, and there's adze marks and axe marks there that someone had used to shape it. And then we uncovered an amphora, brought that up, and you could see the thumbprint of the person who actually made that. And so those, to see those human connections and bring that in isn't just another way that we can use to inspire people and get them in touch with the deep ocean.
Yeah, I often think of the work that you guys do. It's like, for the deep ocean, the imagery, the excitement that we get in the public, it's the ocean exploration moment, similar to what we have in space with the Webb telescope. It's the work that you guys do and the things that you find that are so exciting. And thank you for...
Well, say if we could get that funding that they got for that space telescope, that'd be awesome.
Working on it. I don't want to leave our audience members standing for too much longer, so please ask your next question, and then if there's an electronic question, I'd like that one next.
Yeah, I'm happy to wait for all
There you
the
go.
sea stories to happen. If we build this as telling sea stories, this room would be packed, right? And that human connection is kind of where my question is heading. I hear from the panelists a lot of consensus around our excitement, and I think everyone in the audience shares the excitement of new technologies that are pushing the boundaries. That's kind of what we're here for, to develop our sea stories and learn more. So in the spirit of someone who shares that passion for, my teams do undersea modeling, biomimetic, tech and innovation. I'm drawn towards the technological solutions. So I'm going to ask a provocative question about what are the alternative perspectives that we might be missing here, and how can we pull those in? And so I'm thinking of opportunities like reaching out to the Polynesian voyaging societies, the small island and coastal nations that have really close connections to and different perspectives or perceptions of the ocean environment. Or even citizen scientist efforts. Are there initiatives or strategic directions, ideas you have to pull that data in, to blend with the high tech, to merge with our desire for really high resolution data, to, in the end, develop a more integrative idea of what is the ocean made of, what lives there, and what's our connection to it?
That's a great question. I think it's starting to get kind of baked into ocean exploration, at least the connection with the kind of indigenous people of the area where there's exploration happening. So our partner, the Ocean Exploration Trust, has been doing a lot of work in the Central Pacific around the Hawaiian Islands, and so they've invited kind of Hawaiian thought leaders and Hawaiian language speakers to both connect with Hawaiian language students, in the way that they normally do, but also to kind of work within the knowledge of those people, and bring that into the discussion. And very much like I said about technology taking a long time to develop, I think that truly integrating indigenous knowledge with what we do is also going to be a fairly long process, and it requires building a lot of trust and building strong relationships that are underway, and I'm pretty optimistic about the future in that regard.
Yeah, I agree that bringing them into the conversation is definitely the first step, and NOAA Ocean Exploration has been really, really good about that. A program that we're doing with SOFAR in partnership with NSF Convergence Accelerator, we also just got a Phase 2 award, is a program called Backyard Buoys. And the idea is get our technologies in the hands of indigenous coastal communities and see what do they want to be learning and exploring about the ocean. It shouldn't just be about us coming in saying, well, we're gonna, take this data and bye. No, that's really not a good partnership, and it's also not creating value for those communities. But when they have the opportunity to engage deeply and to make decisions using the technology, then you can achieve things that are really cool. So with these backyard buoys, they're given to the communities, they're trained on how to use them, they're trained on what different types of data they can gather and what they can do with that data. And they have questions too about, oh, can we do this? Can we do that? What is this going to do for my community? And then we say, okay, now it's up to you to decide, where do you want to put these? And so it's not us coming in and saying, we're putting these here and like that's how it is. It's no, like what's going to be the most valuable for your community, and we can help advise if they have questions, but it's really up to them to put that technology to use.
And I would say from an ocean mapping perspective, there's been a big push from the International Hydrographic Organization to do crowdsourced bathymetry. And NOAA leads that effort, but it's basically establishing some standards. Good, Tosca's good for that. Some standards for folks who want to go out and collect data. And it's surprising, a lot of folks thought initially, well, we could just put an echo sounder on merchant ships. Well, merchant ships tend to go the same routes back and forth, so you don't really get any new info. But when you start talking to the sailor who's going to go through the Northwest Passage, that's very valuable data. Or you talk to, believe it or not, super yacht owners who have a lot of money and want to spend it on things, and they think it's really cool that they could put this echo sounder on their super yacht and then drive around the Mediterranean or the Adriatic and collect data. We'll take it wherever we can get it, but we still need to make sure that it's quality data. There is a process then to evaluate it for quality and say, is this data useful? And in most cases it is. And I know Canada engaged their indigenous communities with it was called a hydro ball. Again, similar, it's a buoy, but it has an echo sounder and a GPS, and especially fishing communities, they would ask them, tell them what it was, what information it would provide. They could then, when they go out in their fishing vessels, to go out and actually deploy these hydro balls during ice-free parts in the Arctic, and that provided very important information. So every little bit helps, and I think there are a lot of good initiatives underway to engage those communities, but also to engage other communities who you may not have thought would provide that kind of data.
Kukani, do you want to add?
Yeah, this is a really important, question and challenge that the community faces. So I'm so glad you asked the question. For example, one of my, dearest collaborators, Katie Croft-Bell, she started the Ocean Discovery League. Her group has spent a lot of time thinking about low-cost imaging, and, they've created these low-cost camera systems and called Nakanu, and have made them widely available to, not only local indigenous communities, but also internationally. And providing access to the low-cost hardware, training, and then also thinking about, well, what happens with this information once it's collected? And that's actually a big part of the reason why we've created this Ocean Vision AI program, where FathomNet is actually part of the program. And the idea being is that whoever you are, if you're collecting visual data, we can create a network of individuals, from a wide range of areas of expertise to help process this information in collaboration with artificial intelligence. And so one of the things too, yes, there's indigenous communities or other groups that are, often excluded from oceanography. But then there's also groups that just don't think about the ocean at all. One example is, for instance, we did this FathomNet workshop, and we had great representation from groups all along the coastlines, but no one in the Midwest. And so how do we reach these groups or these individuals and connect them with, the very real challenges we have in the ocean? And that's part of the reason why another activity we have within the Ocean Vision AI is thinking about how we can incorporate gaming and game design and have people not just as a citizen or community science activity to help annotate things, but actually contribute directly to, discovery, getting credit or, attribution for contributions, but doing that through a gaming platform that can, engage a wide range of individuals, and through that whole process, learn about the ocean, learn about the life that's there. A great example I like to give is like Pokemon Go, that game that you may have noticed random members of your community wandering your streets and your neighborhood. These are individuals that were looking for Pokemon, fake animals. And can we kind of garner this excitement around gaming and life and apply that to the ocean? And so that's, again, another way we hope to be able to broadly engage people who don't often are involved in ocean exploration.
Kakani, I have a 10-year-old boy who's willing to beta test for you if it's at all like Pokemon Go.
Excellent. Thanks, Adam.
Can we, unless you have anything to add, go. Let's go for the virtual questions.
Yeah, so we have 2 virtual questions. I'm going to read them both for time purposes, and maybe you can speed round them a little bit. So the first one is regarding like priorities, and Diana Haas online is asking, how do you balance the data collection motivations of need, for example, collective climate action, versus research curiosity and discovery? How do you sort of prioritize those values? And the second one is around garnering our next generation of ocean explorers and engineers. And they are asking, for students and people at the very start of their ocean science and engineering careers, what skills do you think are the most valuable on your teams? And are you finding a greater need for data science or ocean science experts? And that is from Reagan.
Kukani, since it's been hard to call on you, do you want to go first?
That's fine. I feel like the first question might be more towards the we are folks, but the second question, I think we've mentioned this a few times. We think that the value of data, interacting with data, big data as an important perspective or approach within our knowledge, or increasing our knowledge within the ocean, is important. And so, within my group in particular, I'm seeing the increased need for data science skills, software engineering skills, but also ML, AI skills. Like how do you train algorithms? How do you deploy them? How do you make them more performative? And so in the type of work that I do, and in the problems that we've been addressing more recently with FathomNet and Ocean Vision AI, is like those skill sets are very, very important.
Speed responses?
Yeah, I'll add to what Kakani said, that we have a couple internship programs and that are targeted towards groups that might be underserved, and when we go to kind of community colleges, we can't really find people who do biology or geology. We find people who are learning technical skills and want to work on data science, and I think that's great because not necessarily thinking about people coming into my lab and getting PhDs, the kind of blue workforce, for example, they're going to need a huge number of people with those technical skills, and I think it's just a great path for people to take. So I'm really excited to get them interested in the oceans and steer them on that path, because I think they'll be really successful with it.
I'll jump into the first question about how data is prioritized or data collection. And really, I think as much as we can prioritize collecting data that's going to have multiple uses. So maybe it's driving something around a very long-term project around climate, but maybe it's also something that's useful in the moment for an operational need. Let's try to get as much as we can out of that data. And then on the workforce question, interdisciplinary, I think, is a word I've heard a lot throughout this conference, but I would just chime in on that. The technical skills are really great, and as well as the openness to learning about a unique field, oceanography or biology. And one more thing I'd add is the people skills, teamwork, ability to communicate effectively. That helps us get things done a lot more happier and faster.
So 45 seconds. Do you have a last response?
Just real quick on the prioritization. I mean, that's a key question. As a federal agency, we get asked that in multiple forms, many times, in many different ways. And it kind of touches upon what Tosca's saying, is that for ocean exploration, what we're doing is we're providing the baseline data and information for which other people can make other decisions, whether that's the climate science, marine protected resources, nautical charting, safe navigation. We work with all of our partners on that, but if we can explore, come up with that data, that helps us set those other priorities. And that's, luckily we're fortunate right now, as a federal agency, to have that support, have that understanding from Congress and from the administration. It's key because, I'm looking at Dr. Kapnick, don't forget, she's chief scientist for NOAA. there's the ocean side, the weather side, climate side. What we're talking about today is just one aspect of an entire portfolio within an agency that's responsible for so much, and we're just one federal agency. So we try to do whatever we can to make sure that we're helping out all of our partners from a one NOAA perspective.
Good question. Okay. So Jeremy, can you take us home?
Yep, we'll wrap it up. Just want to thank Dr. Kapnick and all of our panelists here for providing your thoughts. One of the big cornerstones and bedrocks here for ocean exploration is curiosity. And for me, I'm always very interested to hear your all's perspectives, all of our partners, and then that conversation continues. We always have an open door, and certainly here, not only whatever discussions that we have today, follow-on aspects, just understand that we're listening. So thank you all, and a round of applause for our panelists and our moderator.
Thank you again to all of our panelists and speakers today. It's been a fabulous day to Oceans. And on behalf of the local organizing committee, we would like to welcome you to join us at our gala tonight at the Nauticus and the 5:45 from the hotels. So they will not be leaving from the conference center, but from the hotels. So please join us and look forward to seeing you there. Thank you.